I'm Condi, and this is the 7th video in a series of 10 that address the frequently asked questions that I get about chromosome 18 abnormalities. And so in the previous videos, we've learned that chromosome changes, chromosome abnormalities, chromosome variation, whatever you want to call it, can be very, very small. But they can be big enough to include a gene. And sometimes those genes make a difference if you have a deletion or duplication, and sometimes they don't. Oh, it gets so complicated so fast. But how does all this apply to someone with a chromosome 18 condition? It's the million-dollar question, right, that each family needs to answer. So again, anything you can do to this picture with scissors, glue, and a copy machine can really happen, and it does really happen, which means there's like an infinite number of chromosome abnormalities. So you can't have a syndrome description for every single one because they're almost infinite. But there's only just over 21,000 genes in the human genome. So really, there can be an infinite number of variations, but there's really a finite number of genes involved. So we need to really base our information not on a syndrome, meaning a deletion that someone has as a defined condition, but based on the various genes that are involved. And so if you've seen with some of the previous videos, we really think only 10% of all the genes actually have an impact when you have one copy instead of two, or you have 3 instead of 2, or 4 instead of 2. And so that means we're really in the whole genome talking only about 2,000 genes. That's not quite as impossible sounding. In fact, it's quite doable. And when we think about how this began, I guess, in 1990 when we began this quest, this was the kind of information that was out there on chromosome 18 abnormalities. It was very just sort of observational, growth deficiency, obnoxious behavior, long hands, etc. And the management part was really wait and see. So this is what we're really trying to change, is to be really specific for specific people about what they are at risk for and how to manage it, and ultimately how to correct those problems. So imagine here is a unique deletion. The box shows the region of this person's deletion. This could be anywhere. Pick a spot on chromosome 18. It doesn't matter. But in this case, it's a terminal deletion of 18q that this person has. And so what we can do is, because we know the genes that are involved now, very specifically which genes are involved and which ones aren't. And we also have some information about which ones matter and which ones don't. So we can create a personal syndrome description for this person that is a combination of the information on 5 dosage-sensitive genes, the 5 genes that we think not do, but can cause a problem when you have one copy instead of 2. So, bottom line is that it's not hopeless. It may be complex and multifaceted, but if you look on the website for the Chromosome 18 Clinical Research Center, you can actually look up each of those genes and learn what we know about having a deletion of those genes, and you can create a personalized management guide. In fact, there's a YouTube video exactly about how to do that if you need help, if you need a walkthrough on how to do that. So it's not hopeless. It's not a complex tangle that you can never sort out. We're sorting it out. And yeah, it's complicated and it's multifaceted, but we can do this. It's not impossible. And it's going to change. We have a very, very long ways to go because at this point we're able to be a little bit predictive, but we're really not there for treatment for all these things. But we'll get there. We just need to work on it. And it's going to take some time and some money and some effort, but we're we're on that road. That's our quest, and we'll get there. So stay tuned.